I'm looking at with December 2023. That is question 4. Okay, let's take AC machines is gonna be part of the test. Okay. From is synchronous alternators. Alternators in parallel right up to the voltage regulation of alternators. That is the first question. So, question 4.1 says, explain what is meant by a distribution factor of a synchronous alternator. Its distribution factor is the ratio of the actual EMF obtained to the ratio of the EMF that would have been obtained if the conductors were concentrated in one slot. Okay, that is the theory side of the question. Then the calculation side, the following information applies to a three-phase star-connected alternator. Open circuit terminal voltage 3300. Its frequency is 50 Hz. Its speed is 1000 revolves per minute. Then is what it number of slots per pole per phase is 4. Its coil span is 150 degrees. Then the useful flux per pole is 55 milliwebers. That is the useful flux per pole. But again, we'll calculate the number of calculate the possible number of conductors per slot. Okay. So gonna go through the given information again. We will open circuit voltage, which is the line value. I always say given voltage is always the line voltage. That is 3300 volts. Then they give us the frequency. Hertz as usual. Then they give us the rotor speed, which is 1100 revolves per minute. And let me explain this now. Given speed is always the rotor speed, unless the question is by synchronous speed, because they know that the synchronous speed here was obtained by that. Then we are given number of slots per pole here, that is equals to 4. Then I got 8.5. That is 150 degrees. Then I got full flux, which is 55 milliwebers. Okay, and we are asked to calculate the number of conductors per slot. Meaning, in order for me to do this calculation, I need to know what is the total number of conductors and what is the total number of slots. Then we divide the total number of conductors by the total number of slots. Okay. The first thing that is easy to accomplish is to find what? Number of slots, nah? Because I am told today I have what? Number of slots per pole per phase. Okay. That means if I want to find the number of slots, and they say number of slots per pole per phase is what? It's 4. That means if I want to find the number of slots, I must multiply to cancel out division. Pair means division. I must multiply by the number of poles, then multiply by the number of what? Phases. Okay. Okay. Then I'm thinking here, I might have to correct myself. I don't know why they are in synchronous what? Speed layer. They just give on speed. But it becomes apparent that in order for me to get the what? Number of poles, it means that as a speed is on synchronous speed. Okay. Okay. So how many number of poles will be given in synchronous speed? Then we're gonna say of what? P. Then we can say motor speed full load. Speed. So here now we have 1000 wells a minute. Now 560 times what? 50 over what? P. So I'm making P subject of the formula. So P is gonna be 60 times 50 divided by 1000. 3. That means how many poles we have? Remember, P on a pole pair is not the total number of poles. So this is a pole pair. So there are 3 pole pairs. That means the total number of poles is you multiply that by 2. Okay, what? Okay. Let's take Pana. Let's say apa? Ubano, pole, 4 number of slots per pole. Okay. So I'm going to multiply that 4 by 6. Therefore, the number of pole per what? Per phase. And then, so that means it's going to take the number of what? You also have number of slots per phase here. Number of slots per phase, that is going to be 4 times what? 6, which is 24 now. Okay, thanks. Then I need to multiply by the number of what? Phases. Then I'm left with the number of what? Slots. Then. So how many phases do we have? We are dealing with a 3-phase what? Question. We are dealing with a 3-phase question. So there are 3 phases. Then I'm gonna get the total number of what? So 72 total number of what? Of slots. Now I need to find what? The number of conductors. And obviously I'm going to use the EMF equation. That is why I was given that EMF. EMF equations here. I must convert that what? Line voltage to what? Phase voltage. 2,22 flux pitch factor, frequency, distribution factor, set P. The formula must be over formula sheet. Ayiko. Nkona na? Yes, ikhona. Ikhona, but I see that ikhona error mole. Endibona William from sheet because babele bafaka u2 Yeah, wrong. Baby, maybe I take 2,2, not 2 only. 2,22. We must account for like 2,22 value from in form factor, that is 1,11. Okay, and these are the things that I must inquire regarding doing workshops. Okay, everything is there now. And that's that conductors per what? Per phase. One of Z per Z, what means is the total number of what? Conductors. So I want to find the conductors per phase. Once we find the conductors per phase, it means I would multiply that value by 3 in order to get what? Total conductors. And it is conductors per what? Per phase. Okay, but first I must convert So the open circuit voltage into the phase. The question is if it was delta, there was no need to do that because the line and phase voltage for delta so phase voltage is our money 3,300 divided by the square root of 3. Okay. Now that I've found a voltage, I can substitute and solve for what is that money? Or I cannot do that. Just Z because it's a shorter values. Shorter money. The pitch factor and only. The distribution factor. The pitch factor, the balance on. We are dividing the angle then. The angle must be symbol no ability alpha or anything, but that's a symbol for an angle. But what we call that angle, we call it a short chord what? Angle. And this is how we find it. We have what? One pole. Then we have what? The adjacent what? Pole. And ascertain the distance from the center of one pole to the center of the angle from the center of one pole to the center of the adjacent pole. You know what I mean? Pole pitch. And the pole pitch is always equals to 180 electrical what? Degrees. Now, the equal span is the angle between the sides of a what? Coil. Right here is span for how long? For how many degrees? The equal span is 150 degrees. Meaning which the angle, the short chord angle again, okay, it's gonna be 180 minus 150. Is there? That angle is there, don't it? It is the pole pitch angle minus the coil span angle. That is gonna be 80 degrees. Khumbule ke inhlobo ngenhlobo ebuzwa ngayo lemali ofuza ngayo mhlawumbe kuthiwa short coded by 2 slots or yabantu ezinjalo. Bani pitch factor yethu 0.966. It's what I don't know. Get distribution factor. But also corner formula shape side mu. La mu is not for what? Efficiency. Mu is for number of what? Mu only mu is number of slot per pole per phase. Not the balance zone. Otherwise, just put it. Okay, I've seen alpha of money or alpha. In place of alpha, is alpha bunting. Y, na? Okay, which is the slot page, na? Okay, so I'm going to put notation, na? How do we find alpha? 180 electrical degrees over slot, say what? Per pole. Okay, how do I get that slot per pole? Remember, a number of slots per pole per phase. Now, in order to get number of slots per pole, I just need to multiply by the number of what? Phases, which is 3. So I'm going to multiply 4 by 3. Mana 12. So I'm going to have 180 and then divided by 12. What is the answer? The answer is 15. So now I can calculate what? The distribution factor okay, let's go new money. So it's sine mu, which is 4, then times alpha with the money 15 divided by 2. Then 4 sine 15 divided by 2. Now as you calculate then in tangent. Right? 0.958. A binary distribution factor and pitch factor normally range over by 0.9 something, whatever, not over, it goes by the year or sharp below 8. We have found the distribution factor. Now we can use our EMF equation completely. Let's take EMF command. 19, 0, 0.5, 256 equals to 2, then times 20. Let's say flux of band 55 milliwebers times 10 to the power minus 3 times the frequency into 50 times E distribution factor of 0.958 times 1 pitch what? Factor na? The pitch factor here to money was 0.966 times conductors per phase, na? The one that I'm making, it's the subject of the what? Formula, na? So that means everything, since everything is multiplying, that means I'm going to divide everything on the left hand side to the, you're on the right hand side to the left hand side, na? So, what's that P way to go on money? Divide another so as values the left, let's divide the side. Solving for Z money P. We are solving for one Z P, the equation. This one. That's the equation. Okay. So I'm not teaching math. Should have acquired the skills of making the subject of the formula. Manaman. Sorry. 90.5,256 divided by as a factors in our pair. Banyak 337,229. Yeah? That is the conductors per what? The phase. Nah? That means in order for me to get the total conductors, I need to say conductors per phase multiplied by how many phases? By 3. So it's about 337,229 times 3. The woman is the total number of conductors. Okay. 687. Yeah? Now I have the total number of conductors and the total number of slots. That means I can find the conductors, the slots, (687) divided by 72. Calculated the number of slots as 72. And my answer? 14,051. So you round off to the nearest what? Height. Yes, so to money. Here are 15 conductors per what? Per slot. If you get a comma, you round off to the nearest highest what? Whole number, sorry. And if you are getting 14,0 what? Then we're gonna round off to 15.